Hello. Today's lesson is on establishing congruent parts in triangles. So this is kind of the start of the triangle proof unit. So what we're kind of saying here is, let's suppose that we have, two triangles that are congruent to each other. Congruent, of course, means same size and same shape. And we might want to think about why are they congruent to each other. So maybe I'll call one triangle, ABC, and then I'll call the other triangle DEF. And one main idea that we're going to be looking at is just kind of like matching the pieces of evidence. So we have this terminology that's called CPCTC, which stands for corresponding parts of congruent triangles are congruent. So for instance, A and D match with each other. So I could say that angle A is congruent to angle D. And if I'm designing something, I might want to kind of, if I want to make things that are congruent, same shape, same size, I may want for those angles to be, equal to each other. So I mark it in the diagram as such. I could also say, for instance, that angle B is congruent to, you may want to think about that before I fill it in. But E is kind of, in the same location. And we could also look at sides. So the distance from A to B is the same as the distance from D to E. So a lot of times congruent parts will be, kind of given to you in the diagram. However, you might see some situations where there's like the words bisector or vertical angles, or maybe the fact that the triangle is isosceles, that will kind of give it away. And then this reflexive property thing over here, this is kind of useful when maybe I have like two triangles that are kind of next to each other. Maybe they form like a quadrilateral, but a side could be, congruent to itself. So let's actually take a look at some of the examples. Obviously, I want to make sure that you are kind of working on them in class first before you watch the video. But let's kind of take a look and see what the examples are like. All right, so example one, this says that the two triangles are congruent. So you're going to find EF and the measure of angle D, and then write a triangle congruent statement. So our goal is that we want to be able to match the pieces of evidence. First things first, I actually just like to go and match my pieces of evidence right off the bat. The 130 is the obtuse angle. So that means that the obtuse angle in the other triangle needs to be 130 as well. Another thing that I can kind of see right off the bat here is I have my short side measures 2.5. So I'm going to put that right there. And another thing that I can see is that that side that's next to 2.5, that isn't the longest side, has to be 7. And it turns out that EF is equal to 7. So that's kind of the quickest and easiest one. And then I can kind of put where the 18 is as well. The problem is that they want us to find angle D. So I'm just going to call that X for right now. But I could just do 18 plus 130 plus X equals to 180. And when I solve for X, that's just going to be 32, I believe. When I name the triangles, I look at what points correspond to what point. So D matches with I. E matches with J. And then I can say that F matches with K. And that concludes example 1. Let's take a look at the next example. Example 2 says, use the information given to mark incongruent parts in the diagram. So we're going to go ahead and mark what is given. So first off, I have A, B, C, and I'm just going to kind of do this in multiple colors here. I'm going to start with the blue. So I have A, B, C is congruent to angle GHC. So this is given to me. So a lot of times when we do proofs, some of the stuff that we're going to have is going to be already given. Next, we're going to use a different color to mark in AC and GC. So my green side, so AC and GC are congruent to each other, and I'm going to mark in the tick mark to kind of show that side length. And then last but not least, it tells us that C is the midpoint of BH. And actually, I'm just going to get a third color here to show you all that. Red for that. So here's C, and midpoint just means point in the middle or halfway. And I'm going to just kind of put that midpoint right on that red line. And then that red line cuts exactly in half. And there is our information that shows that both sides are congruent to each other. All right, and then last but not least is number 3. This kind of introduces us to the proof level thinking a little bit. So this one, I am going to kind of use my markers again, just to kind of show us here. So first it says that ILK is congruent to angle BLK. And remember, when we name our angles, we're just connecting the dots. Question is, what is this vocab word? Well, it turns out that this vocab word, wait for it, actually think about what it is before I tell you, is drum roll, vertical angles. All right, next we have KL and AL. I'm going to go ahead and actually use green for that, but I have AL goes from here to here, and it's kind of marked in with a congruent marking, and then KL is also just like that too. But if it's already marked in the diagram, we write given. This actually kind of introduces us to a proof. And then we have IKL and BAL. So I'm just going to use a third color on that. IKL and BAL. And remember, the zigzag is kind of an alternate interior angle. And that concludes the lesson 5.1.